Hello, we're team number 2 and we're going to present you Newton's law. We will use examples in our presentation to make it easier for you to understand, and we would also add a conclusion at the end. This work was done by Sofia Gonzalez, Itzel Quirino, Cindy Lopez, and me, Gaby Payan. I'm going to explain the inertial law. This law established that when there is no force upon an object, that object will have to remain static. And on the other hand, when there is a force on an object, if it has a constant speed, it will continue having that speed.
Example of law number 1. One example of the inertial law is a soccer ball and a player, because the ball will remain static unless a player applies an external force, which is in this case kicking the ball.
This is also known as the law of motion. This is about how the acceleration of an object depends inversely on the mass of the object, but it depends directly on the amount of force you apply to it. And this law has a formula, which is F equals ma. It means that force equals mass times acceleration.
Example of law number 2. An example of the law of motion is a supermarket car. If we take a car full of products, it will be harder to match an acceleration of a car that is empty, because the acceleration depends inversely on the mass of the object.
This one is the most known because it happens all the time. Sometimes we don't even notice. This one is the action-reaction law. It establishes that every action that is made will have a reaction force equal in magnitude but opposite in direction. This has changed the way we perceive the world as it is. It was a very important contribution.
Now let's go with an example. One interesting example of this is when the game of pulling the rope is being played. Two people are pulling it in opposite directions, and the force is applied to the rope, not to the person, but it occurs between the person and the rope. By doing this activity, we were able to learn in a deeper way what some of the Newton's laws establish, as well as identifying the way that they are presented in different activities in our daily lives. And they will help us also to analyze situations better. After we finish, we conclude that these laws are more presented in our daily context than we can even imagine.
Thank you so much. I hope you enjoyed our presentation. Now, we're about to see the video of us solving the logs. Okay, we're team number 2 and we're going to do the activity of the, how do you say candados in English?
Lux.
Lux.
The logs. Thank you, Sofia. Well, in my team, we are Sofia Gonzalez, Itzel Quirino, and Cindy Lopez.
Can I read?
Yeah.
Nació en Inglaterra. Fue uno de los científicos más brillantes que ha tenido el mundo, quien formuló las leyes fundamentales de la mecánica, así como la ley de la gravitación universal. Para sus fórmulas, tuvo que inventar métodos matemáticos de cálculos y otros más de sus trabajos científicos. Fue el descubrimiento del espectro de colores de la luz blanca cuando pasa por un prisma.
I think it is Isaac Newton, maybe?
Yeah,
Maybe.
Because of the... Mm-hmm.
Yes.
yay!
Okay.
The second one.
What's
How many triangles are in this picture? 3. 1, 2.
The big one and the
Uh-huh.
And
one
then,
that's smallest.
Oh, yeah, you're right.
That one was easy.
yes.
I hope all of them are like that.
I want to read.
Uh-huh.
Es una característica vectorial que mide la intensidad de la interacción entre dos o más objetos. Esta interacción puede ser por contacto o a distancia.
Masa, maybe? Or do you
But
have it?
it's
No.
vectorial, right?
Oh, that's true.
It measures the intensity between two objects.
¿No es fuerza?
Try.
No entiendo.
Oh,
¿Quién quiere? Who wants to read? Sorry.
Me.
okay.
Es la cantidad de materia que posee un cuerpo y también se puede definir como la cantidad física escalar que mide la resistencia que presenta un objeto para que adquiera movimiento o bien para modificar su condición de movimiento, o sea, el cambio de velocidad. I think that because it says materia que posee un cuerpo, we're talking about
Masa.
mass.
Porque el volumen es,
Yes.
pero it's different,
Mm,
right?
But
I think it's
we
mass.
can put both of them to see which one is correct.
Okay. First, masa.
¿Pero es masa o volumen?
The same thing, I think.
Oh.
Okay.
Okay, the third one.
3.
¿Cuántas veces en Newton? 3.
They are 4, right? I think they are 4.
The teachers,
4.
like the math teacher, told us that they were 4, but we have only seen 3 in class.
3.
So maybe.
Ajá.
Oh.
Yeah.
The inertia.
De que lo que se queda para, o sea, que si es un objeto no se está moviendo es porque no tiene fuerza en él,
Ajá.
¿no?
Sí, hasta que pones un... Till you put an external force.
Yes, sorry. Mhm. Thank you, Cindy.
Esa me toca a mí.
Ajá.
O sea, explicar, déjenme acuerdo. Es fuerza igual a masa por aceleración, pero se encarga de cuantificar la fuerza.
Fuerza. Yeah. Wow.
¿Cuál es la tercera ley de Newton?
Acción y reacción.
Acción, reacción.
Acción, ¿cómo lo escribo así?
Pues lleva acento,
Sí,
pero
para
no sé.
poner los acentos nomás. Chance y más vale, ¿verdad? Epa.
I think you need to put acción y reacción.
O a lo mejor así. ¿verdad?
Ajá,
¿Verdad?
try it.
Eres un ganador. Qué
Okay.
bonito.
You're winners.
Thank you,
We
Miss.
finish. Bye.
Bye.
Bye.